Six. I thought you said something. No. Ready to go over it?
Ready.
Sure, maybe.
Yeah, PJ, I don't feel the excitement.
Same. I don't feel the love for the math. What? It's gonna be fine. Okay, so we have a couple of different responses here for writing the equation for the function. We have some similarities. Okay. Does anyone have any that we want to immediately push back on?
The third one.
This one? Okay, why this one?
It's always divided.
You're dividing 6 and 2 over 3 versus x.
Say that one more time.
Is that a times, like between 6 and 2?
Yeah, multiplication between 6 and 2. Hey Kyle, we're going to go over some of that understanding check early next week. So just hold on to it, we'll talk about it, okay? So 6 times 2 divided by 3 raised to the x, okay? So why do you want to push on that one?
It's written wrong.
Okay, what do you mean it's written wrong?
It's supposed to be y equals a times b raised to x.
Okay?
There's
My,
no division between
Yeah.
A.
so my guess is this person, and so I do want you to pay attention to this, my guess is this person typed it in as, or these two people typed it in as 6 times 2 divided by 3 to the x. Which, that's close to right, but that's why I ended up writing it like this, because your calculator is going to follow the order of operations. What do I need to do to indicate that the 2/3 is together? Parentheses. So if you typed it in like that, that's why it got messed up to that point. You had to put the parentheses around the 2/3. You could also use the fraction bar, but I don't. Fraction is just division. Just put the parentheses around it. Yes, KJ.
Is it automatically with the FX?
If you look at the calculator, when I designed that problem, I already had the f of x equals. Yeah. Sometimes I have a y equals. Sometimes there's nothing there, and you would need to put the y equals to the f of x equals. But that is a good point. Can you just have that for the exponential function?
No.
No. You had to have it equal to y, so be careful about that. Some of us had that issue on the understanding check on the writing of the equations. Any others that we want to immediately push back on? The last one, why?
There's no, it's adding, there's addition,
So it looks linear in this equation. I do want to point out, looking at this linear equation, what would be the rate of change? Just x? X is the rate of change? So 1 times x is the rate of change? Thought x was a variable.
That would be.
What's the slope? The whole thing right here?
So
No, one's x.
The 1 is my slope,
The
right?
rate of change is 6. I don't know.
I don't like the way they wrote that.
It's okay, but I want y'all, and this is important because I did see this on the understanding check when I was grading it, which is why I'm going over this. What 2 things do you need to write the equation? The y-intercept and the rate of change. Which of these 2 things is the y-intercept? The 6. The 6 is my y-intercept. That's not my rate of change. The y-intercept is that 0, 6, because if you substitute a 0 in, you're going to get 6 out. Remember, and I think this is where some of us are having some trouble, the additive rate of change is also called what? Slope. The slope is the additive rate of change. The slope is the constant additive rate of change. That's something you need to know. And another thing to remember is, how do we mathematically show repeated addition? multiplication. So the x is not a part of my rate of change, it's what I'm multiplying by x. So in this equation it'd be 1. Now, we don't have a linear function. That's important to notice, it's not adding. And I see 3 people said 2/3, and 2 people said 1.5 for our multiplicative rate of change. What do we need to do to figure out what the answer is? Make a table. Don't stare at a graph and struggle to identify that rate of change. Do not stare at a table and struggle with that rate of change. There are 2 things you could have done. I will say, if you had made a table and list in spreadsheets, couldn't you have graphed it in data and statistics and done a regression analysis? Yeah? So let's go back through how to do that, because I do want you to be able to use that to check yourself. I need you to show me the work, but that's an easy way to check yourself in the future. But let's look at the graph of this first. Looking at the graph, not in the 1.1 or 1.2, we want 1.1. So looking at this graph, what are some points that we know right away?
1,4.
1,4.
0,
Notice, what I want is where the horizontal and the vertical grid perfectly match a point. A lot of us on the understanding checks did not identify those points on the graph, and that made it really hard for you to get the equations and the rates of change. Okay, what's another point that I can clearly see? 0,6. And any others?
-1, 9.
-1, 9. So, we had some people thinking that we're multiplying by 1.5. We had some people multiplying by 2/3. Now noticing that it goes from 9 to 6. And by the way, this is important because I'm guessing some people flipped it. Notice how I am going from least in the x to greatest in the x, right? So I have to set my table up this way, right? I have to start at -1 in the x, 0 in the x, and then 1 in the x. If you don't do that, you're going to get everything backwards. What were we going to say, Jada?
On the calculator, I divided 6 by 9 on it.
Right?
And it gave me 3 over 2. I don't know if I did it wrong. So I thought it was 3 over 2 at first.
Okay, do that in the calculator again. What is 6 divided by 9? My guess is you actually accidentally typed it in wrong. Does anyone know why Jada did 6 divided by 9?
Oh, snap.
Okay, Jason, I have no clue, Mr. Kenny. Okay. You are correct, but let me ask this.
Wait,
What
I did it
is-
backwards.
Huh?
I did it backwards. I did
9 divided by
9
6.
divided by 6.
So, does anyone remember what the name of the multiplicative rate of change is? Common ratio. Remember, a difference, when you look at a difference between 2 numbers, what operation are you using? Subtraction. Addition and subtraction goes with what type of function? Linear. So that's something we need to keep in mind, because I saw that mistake on the understanding check as well. A common difference, difference meaning subtraction, that goes with a linear. Here, we're looking at something being multiplied or divided, that's a common ratio. And so you do the ratio between the current value and the previous. It's always the current to what was previous to it. And when I do that, what do I get? 2 divided by 3, or 2/3. So what am I repeatedly multiplying by? 2/3. Now, I do want you to show this kind of work to be able to get that equation. But I also do want you to remember, if I go to a list in spreadsheets, I'm going to do x1, just to make it easy, and y1. I'm going to go -1, 9, right? 0, 6, and then 1, 4. And then now what can I do to figure out what that equation is? What kind of page am I going to add? I already have list in spreadsheets. So data and statistics, right? So is that okay, so data and statistics. And what's going to go on the x-axis? x1. Y-axis? y1. And now what can I do to figure out what the equation is? Regression analysis, right? Now that almost looks linear, doesn't it? But we already know, based on what we saw earlier, that it is what kind of function? Exponential. So analyze, regression, show exponential. 6 times, what does 0.6 repeating end up becoming? 2/3. 6 times 2/3 raised to the x. So this is a good way to check yourself. Now, I'll point out that decimal right there tells me you did the regression analysis. I'm okay with you checking yourself on the regression analysis. Heck, I want you to remember, and still no one's done this, and I hope someone does this in the future, but you can still bring in a laptop, a tablet, something like that, and I can download this software onto that device so you can use this at home and get practice doing the regression analysis to help you check your answers, make sure you get these things right. So take advantage of that, but 6 times 2/3 raised to the x. Any questions about this function or this equation before we move
How
on?
do you, on the calculator, how do you make that to a fraction?
So if I create a calculator page, okay, so I'm going to type in as far as I can go, just for a while there, to really make sure it looks like 0.6 repeated. What single button does most operations run through? Menu. So I'm going to go to menu. Do you see any options there that might give us the ability to go to a fraction? Number. We're dealing with numbers, right? So go to number. And approximate to a fraction, right? So 0.6 repeating, approximate to a fraction, 2/3. Now, if you don't go far enough with the 0.6 repeating, it won't get the 2/3. So you have to type in those repeating decimals pretty far out.
Oh,
Does that make sense though?
I didn't know that.
So.
I have to.
That is a good thing to ask about, especially if you ever look at the ACT. Almost everything on the ACT is in fractions, very few is in decimals. And that's because the ACT is designed so that if a student doesn't have the resources to have a calculator, they can still get every question right. Because you can actually solve all the questions with fractions, it's not as easy with decimals.
I don't like fractions.
They're much easier to work with long term, but, because like, here's the thing, like, legitimately, all you have to do is simplify, right? Like, take 6 divided by 9. Fractions are only bad with adding and subtracting. Multiplying, dividing, fractions are way easier.
I used to hate adding and subtracting fractions because it was.
Right, adding and subtracting fractions is rough, but I want y'all to think about it. Anybody have a clue what 0.6 repeating times 0.45 repeating is?
No,
No ideas?
not even on track.
Not even a little bit. Okay? But if I had given you the fractions of those to start, 2/3 times, that'd be 45 divided by 99. Still not pretty, but I will point out, 45 divided by 3 is what?
Oh,
I don't know.
15.
15, okay, so 45 divided by 3, so I get a 1 here, I get a 15 here. Hey, what's 2 times 15? 30 divided by 99?
3 point something.
3 times 4 is.
1 times 99?
Oh,
99. And so notice I can actually simplify that again. That'd be 10 divided by 33.
Yeah, that's still.
Yeah. See,
Is that harder than 0.6 repeating times 0.45 repeating?
No, it looks.
No, it's not. And that's the point I want you to understand. Multiplying and dividing with fractions is much, much, much easier than multiplying with decimals.
I forgot how to do stuff in my head.
I'm okay with that though. I'm all about the calculator life. Let's be clear. Okay. So review the second equation here. So -2 times x minus 3 plus 2. -2 times x plus 3 minus 2. Oh. I have to point out, well, so I have one student who noted vertex form, but there's something wrong with this, and this that hurts my soul.
Why? There's no
Say that one more time. Hey, y'all, this is what kind of function? Quadratic. What do you need if it's quadratic?
Oh!
Oh!
That's the only thing I forgot.
Like a big name.
No,
Oh.
we've gotta be careful about that. That square has to be there,
On
okay?
vertex form, I'm just used to like,
Y equals
I
mx
look
plus
at
b,
I look at the 8x and the h and k.
okay?
I didn't notice the exponent.
I got you, but be careful, you gotta focus on that exponent, because it's quadratic. I wanna point this out, a is equal to -2. Does that mean that the -2 is being multiplied by a?
No.
No, that means -2 can be substituted in for a. A is equal to -2. Now, I see some of us with x minus 3 and some of us with x plus 3. Which one is it supposed to be? Minus a, but remember it's minus a -3, right?
So would that be added?
When you subtract a negative, it becomes positive. Remember, when it's the x minus the h, x minus r1, isn't always the opposite sign? Do we remember that detail? Okay. Raised to the second, then what? Plus 2. Please also note, this is important, is it an equation if we don't have the f of x equals to the y equals? No, you gotta have that in there. Last detail, just small things. Make sure if you're writing it, you put the square outside the parentheses. Because I'm not squaring just the 3, I'm squaring the x plus 3. Does that make sense? We good there? Ready to move on? Any questions before we move on? I want to make sure we address these. Okay. So, as a quick reminder, this is a math class first off. Not drawing class, okay. Math class, but as a reminder from that, like I've given you the understanding check back. The understanding check is literally just that, a check on your understanding. Yes, I scored it, yes, I graded it, yes, it's going in the grade book, but is this score final?
No.
No. It is an understanding check. One, I'm going to make sure I go over a couple of things based on where I saw the scores, but two, right, and that's why we actually had that first bell ringer, because we still need some practice specifically on writing the equation from a graph. Hopefully we're understanding that a little bit better now, right? Recognizing how to identify that type of function from the graph. But we are going to continue working on it, and I will replace that understanding check grade. How and when? After the test. So if you improve your understanding from this understanding check grade, and you do better on the test, you're going to have a higher score on the understanding check. And if you go in and you look at power schools, you'll even see I make a note of, hey, originally you had this score, you now have this score because of the test. You can actually see that comment. I do that every single time. If there is no comment on the understanding check, that means you did not do better, which means we probably didn't learn from our mistakes. It's great to make mistakes. We just have to make sure we're learning from them, growing and getting better. Yes, sir.
When's our test?
Hopefully next Friday.
Ah.
We still have one major thing to learn, which is what we're starting on today. But that means we'll be working on it for 3 or 4 days. One single thing. Now, it is 2 lessons because there's a detail that goes with it. Something called complex numbers that y'all haven't studied yet. And trust me, it sounds complex because someone named it that way.
It's easy.
It's not bad. We'll talk about it. Okay, getting away from that though. So let's get to today's lesson. So we're going to wrap up activity 4.3 today. And what this is all about is kind of what you actually did in the bell ringer, that second question of writing a unique quadratic function before we start talking about the root of the problem. And so again, we're trying to identify the different equations of a quadratic function. We got to know vertex form, standard form, and factored form. Are we remembering those equations a little bit better?
Yes.
Yes. So one thing to remember is the more reps, the more practice you get with it, the better off you're going to be, which is why you have to have homework. I try not to make it a lot, but you got to have some homework. You got to have some practice with it. The more time you spend with it, the better you're going to understand it, okay? And then we need to know the features that we can identify even without a graph. So we started just briefly talking about A and B here yesterday, and I need you to take some notes on this. So consider the 2 functions shown from question 1. Identify the form of the function given. All right, let's do all this together. With A, what function are we given?
Back.
Factored form, okay? factored form. And then write the function in the other two forms if possible, okay? So, anybody have an idea what I could do to this equation, maybe to get it to standard form?
Distribute.
Can't I distribute?
Who said that yesterday?
Somebody, I don't remember.
Me? Taking the credit.
Jada said it. So, we can distribute. Now, I want to caution you, and I want to point this out, and be careful about this. If I had -2 times 3 times 4, would I do -6 times -8? If I had -2 times 3 times 4, would I make that -6 times -8?
No, it would just be one answer since they're all the same.
Well, right, but what I'm doing is I'm doing -2 times 3 and -2 times 4.
Why is it -8?
Huh?
Why is it a -8?
What's -2 times 4? But I'm asking this question, should I multiply -2 times each of those numbers separately?
No.
No. I'm only multiplying -2 how many times? Once. A lot of students, because they're used to distribution, are used to, or they immediately want to take this -2 and multiply it by both of these things, and take this -2 and multiply it by both of those things. Should we do that? No. Right? If I do -2 times 3 times 4, I can either do -6 times 4, or I can do 3 times -8. One of those two. I don't multiply it by both numbers, I multiply it by one. To make sure that you don't make that mistake, personally, what I would do is I wouldn't even distribute the -2 first. I would distribute this x, and then distribute what? And then the 1, right? So, I want to give you all about, I don't know, 90 seconds, 120 seconds. Use that information to help you simplify A, also work on B, and then we're going to talk about how to get the other forms after that. Let's get to work. So make sure we're talking with each other. What did you ask? So distribute this binomial to that binomial, leaving the -2 outside. So bi means two, binomial meaning two numbers, right? So when I say binomial, I'm talking about x plus 1. I'm distributing that binomial to the other binomial of x plus 4. Right, so I'm distributing that, and then I'm distributing my 1 as well.
And then after, would we distribute the negative?
And then you would distribute the -2, correct?
Okay.
Where did the 3 come from?
So that would be.
No, I made those up. That was to illustrate
Oh,
if I have -2 times 3 times 4. Remember, I said I'm not going to do -2 times 3 and -2 times 4. I'm just doing it to one or the other.
So you just pick which one.
The x.
That was just an example to help us understand why
You can
that we
pick
don't
which-
do that.
No,
Huh?
you
You can
gotta,
pick which one you want to multiply. Or-
you gotta distribute one.
So remember, you can do -2 times whatever first. I recommend doing the x plus 1 times the x plus 4 and then distributing the -2. It'll help make sure we don't make those mistakes. I would not do the -2 first. So like, you're making it harder than it has to be. Do you know how, if you just looked at x plus 1 times x plus 4, do you know how to do that?
And then you have to combine like terms, there's -2 and x, so that'd be -1.
You can't, what did we say earlier? We distribute, so x needs to be multiplied by, which gives me,
That's what I
X
got.
to the second.
1x.
okay, then x still needs to be multiplied by,
And then 1 times x.
so that gives me,
I distributed this one, and then I did, so I got x squared, and then 4x, and then I did the 1, and then I got 1x. and
That's it.
4.
Oh, so we're only supposed to distribute.
you're talking about add.
So we only distribute
You
to
don't
one.
add them when they don't have the same variable.
Oh.
Because remember, if I have 3x plus x squared,
Then after
well,
that,
those aren't the same at all. But if I have 3x plus x, that's literally 3x's being added to 1x, so it's 4x's. You can't add them unless they're the same.
I did
X squared
into
plus
x.
5x plus 4, just don't forget, I still have that -2 outside.
Yeah, and the 1 and the 4.
So we don't use that at all.
And then I would distribute my
Okay,
-2.
so tell me what you
Yes,
got
ma'am.
after you distributed it, would be.
I got x squared,
So where's the
Okay.
-2 go?
the -2, oh, I just like I didn't worry about it, so I got.
Yeah, go ahead and work on B.
So I'm gonna go ahead and put it in your things, so it'd be like a -2
Yeah,
times.
x squared
So are we all good on this so far?
plus 4x.
Okay, one thing I wanna caution us on, and I wanna point out, we talked about this in the whole class
So
earlier.
then it'd be
So you're just doing the x plus 1 times x plus 4. And so you got x squared plus 4x plus x plus 4. Did everybody get that?
4 plus.
We did x plus 1 times x plus 4. But remember, the -2 is outside of all that.
Plus 5x.
The -2 is not just being multiplied by x squared. The -2 is being multiplied by
Plus next.
Still haven't
everything.
used it.
Oh, yeah, that's right.
Yeah, and
That
I
makes
just took it
sense.
out, so -2 plus 4 is 2.
Well, I'm multiplying.
So the -2 is outside all of that, so it needs to be, just like if I were to have 2 times 3 times 4, or -2 times 3 times 4, it'd be -2
So that's what I'm saying,
times
eight.
12.
Did we distribute?
But no time you need to multiply the -2
Yeah, I
times
just
3
did
is
it
written.
after I like.
So you need to multiply -2 times
Yeah, I'm
3.
gonna wait, I'm gonna do it at the beginning, so I know the first.
Not quite.
Just
Also,
what
it
do you
wouldn't
do
have to be
-2?
-2.
You've already done x plus 1.
Okay, but then it's not being multiplied,
X and
right?
x
So
and
that,
x and-
so we need to now that I have this, what do I need to do?
Okay,
I simplified it.
so -2 times
negative
x to the
2
second plus 5, okay, so it'd be x to the 2x to the second?
Yeah, no, you just put -2 in front of it.
Hey,
So I just did
Multiply
-2.
that.
So this is square.
negative 2x
So now it's,
squared
what's the term of
Minus-
multiplying it by everything?
Negative 2.
x
Minus 10x plus 4,
Do you know?
is that what you got?
No, I got -8. Cause that was fine.
I did too, but it was a 2.
No? What's the term for when we multiply by everything?
After you did -2 times 4.
Starts with a D.
Oh, it's
Three.
minus.
That's all we're saying. That's not what I want us
It's
to
like
recognize.
Yeah, that's what I got.
Okay, I'm gonna like totally
Okay.
map it out.
Okay. Try applying that to B, and we'll get started with that. How's it going over here?
That's my problem with homework.
Hold on a second. What's x times x?
Yeah.
Cause like, I can't tell if I got it right. Usually when I look it up on the internet, there's this old man
Okay.
who has a book from like his
When
grandma.
we multiply something by
And he
itself,
goes through
isn't that
each
the
and
whole
every
point of
one,
an
like,
exponent?
talk it out, he's just like,
I want you to know, is
he's
this
like,
quadratic
exponential
function?
extra, like, he does like, you're
Can
gonna
you do
times
that?
3, 5, x, and you don't do like, just distribute.
Quadratic.
This.
Because what do you need for it to be quadratic?
And then this multiplied by this, and you know,
An exponent of 2,
So-
right?
and then if
So,
you scroll
that should be a
down,
huge
the
hint that
answer,
we made a
you
mistake
don't
there.
understand.
So you
I
were
got
very
that, I scroll up
close,
and see.
but it should have been x squared plus 4x
I
plus
like,
4.
but he doesn't like
Or
it
plus
because.
4x plus x.
Plus
four.
that's,
And then don't forget, you're still multiplying negative 2
like, I
times
like that this class is like,
That's something to consider when you move to B. So update that
But at the
and
same
let's get to
time,
work.
like,
Okay, so we
The way
said
the school
that
works,
we don't
we're
know
not
because
gonna
you
be
can't do that.
like, we really just need you
One
to
of them's
tell the
square.
formulas,
Okay.
stick it in our
I mean,
minds and.
Does that look like one of the forms of a quadratic function?
Have to do it online.
Oh, your standard form, right?
I'm just gonna do this.
Now you're missing something from that standard
It's a
form.
project
Y
form, are we putting it in standard?
Yeah.
Now, you're still gonna have to do one of the other forms, so make sure you leave enough space for
Right,
that.
would you do 2 times x and then 2 times -6?
She does right big.
Because there's not 2
I thought we were doing
bars, so that thing doesn't.
Yeah, but you still need to write the vertex form for this one.
There's a s-
We're gonna do that together, but we need enough space to do that.
2.
It
Well,
says
I
that we're gonna have to do
think
the other
that
2
means
forms of the
x
function.
is x squared and 6 is 6.
So we'll talk about that in a second.
What is 6 squared?
6 squared
36.
is, yeah.
Okay, and then what's the x squared? It would just be x squared.
Yeah.
So 2. Would,
Can you do multiplication before you do an exponent?
Okay,
yeah, besides,
Oh,
just
no,
say-
no,
So-
You also don't wanna do x squared plus 36.
so.
You're forgetting what it means to square something.
So it would be x.
What does it mean to square it?
Minus 6.
What up?
We could just say it's not.
Why are you confused?
which would be what?
It's squared.
2x.
So,
Oh, you're right,
So
two.
it'd be x
Yeah.
squared.
X, yeah,
What's negative 2 times x squared?
so two, parentheses, x minus 6, but then what does that mean?
So what is it?
And then negative 2 times
X
5x.
goes to both, x doesn't go to both of
So-
them, does it?
And then negative 2 times 4.
plus 5.
Since we did appendices.
What process am I using that negative 2?
Okay,
6
so
times
x
x
to
and
x,
then
x,
6 times 6.
is that the x?
6.
Yeah, and you have to do the x part.
So
Yeah,
x
x times x.
times x,
Yeah.
So
Write it
x
out.
squared.
You'll recognize it.
x six times negative six.
Yeah.
You run back.
Negative six times.
Why is it minus?
Well, it is plus negative 6x, but adding the
Negative.
plus is just extra work.
Negative 6
Wait, I just need to know the
What's
actual.
negative
like,
6
X
times
times
X?
X,
It's gonna be a
and then
positive
X times 6,
total.
and
Oh,
then
X
it's
squared.
No, 36.
Negative
And then what's the negative 6 times negative 6?
And then
Negative 36, right, so be careful with that, we're gonna talk about this in a
negative
second.
6 times, that is also negative 6, and then 5. Negative 6
Now be
times negative 6.
Careful, right, so you did the x minus 6 times x minus 6. Isn't something being multiplied by this still?
Yeah, plus
That's
5.
true.
So make sure you put parentheses around that and the 2,
So-
because that 2 is not being multiplied by the 5.
Negative 6 minus negative 6
What's
would be 0, so X is second
So-
minus 3.
Do I keep this in parentheses and
Mhm.
distribute it to all of them?
Wait,
Yes, that's what I'm talking about.
So I got X is second minus 3.
So that'll be 2.
That it goes to
Add
X minus 6 minus
So
X minus
negative
6.
6.
Okay, can you grab everyone's
X is
attention,
second minus
please?
6.
Thank you,
Negative 6 plus 5.
thank you, thank you, thank you. Alright, so let's talk about this, because there's a couple of key things I want to point out here. First off, I want us to notice, what form did we end up with once we distributed?
Standard.
Standard form, okay? And so I need you to hear me very clearly on this. To get standard form, all you have to do is simplify.
Standard form gives us what answer then?
Well, we're just getting standard form for this
I'm
problem.
saying, what does it make? Because when I was doing homework, I was looking at one of those things that like explains it piece by piece or whatever, and it was saying that each form gives you a different part of the equation, like X is like in factored form, what are you trying to get, like what are you making a factored form?
Okay, can anyone tell us what main characteristic we're getting from factored form?
Yes.
X-intercepts.
Okay. So that's what I'm saying is when
What
we're in a
main-
problem, if you can't find the X-intercept, is that when we would change it to factor, you always want us to change it to factor?
No, I will, if I ask you for x-intercepts, what form are you gonna get? Factored form.
Okay.
If I ask you for, I will tell you this, I'm pretty much never going to ask you, no, that's not true. Standard form is just from that process of simplifying. So I might ask you for the standard form to simplify, but vertex form and factored form are where we're getting our main characteristics. But what I want you to write down here, because this is true for both A and B, make this note to yourself, to get standard form, what are we doing?
Distributing.
Distributing and what? Simplifying, right? Simplify. That's the big thing here. Which part of that simplifying is distributing. So to get standard form, simplify. That's it. Now we need to be careful, we need to learn how to do this well. Okay? But I want to point out, most of us are starting to get there, we just have to be careful about it. So x times x gives me x squared, okay? In order for you to have a quadratic function, what does the power have to be? 2, right? If you don't have a power of 2, and it was a quadratic function, you done messed up somewhere. Go back and look, okay? So x times x is x squared, and x times 4 is 4x, plus x plus 4. I'm moving through this quickly because we all got there. Now, this is where I want to caution you. What was being multiplied by all of this? Negative 2. So I am going to make sure that I put parentheses or brackets or something and I keep my negative 2 outside of there. Notice, I'm not dropping anything off from the equation. I am keeping my f1 of x equals negative 2 times all of that. And then again, to get standard form, what process am I using? Well, distributing is a part of simplifying, so what am I going to do? So simplify, right? Combine those like terms, simplify it some.
Oh.
Notice, did I say anything other than simplify? No. It's following the operations you already know to simplify. f1 of x equals negative 2 times x squared plus 5x plus 4. And then what process am I going to use now? Or what part of simplifying am I going to use again? Distributing. That's it. Right? I'm just simplifying all the way through. f1 of x equals negative 2x squared minus 10x minus 8. To get standard form, all we're doing is simplifying. We good with that idea? Yep.
Will I be in second period at 9? 40?
So
No, it's
part
a
B,
question, can somebody answer?
Part
Yes.
B.
Okay.
I saw some students immediately make the mistake that I cautioned you against. Immediately, some of us were thinking x squared minus 36. Meaning we did what?
Multiply the 2 by both of them.
Nope, that's not how we got the x squared minus 36. I'm going to talk about that error in a second. What is x squared? X squared, right? What's 6 squared? 36. But you cannot just square those individual terms. We're going to talk about it in a second. The other mistake that is pretty common that I forgot to talk about is I saw some of us distributing that too. What comes first, multiplication or an exponent? An exponent. So can you just multiply to get started? No, you cannot distribute that 2 because the exponent takes precedence. Because an exponent, remember, is repeated multiplication. If I were you, and I'll be honest, I still do this. Even though I don't have to do the step I'm about to show you, because I've done it for so long, I still do this to make sure I'm not making any mistakes. What does it mean to square something?
Multiply it and
So x minus 6 times x minus 6. This helps you make sure that you don't make a mistake in that distribution process. This helps make sure you don't do x squared minus 36. Go back to what it means to square it, multiply it by itself. Now we're going to take the same process we just did. Now notice again, I'm going to keep my 2 here. Because is that 2 being multiplied by the 5? No. So I want to make sure I keep my 2 here and I show the brackets or the parentheses. So x times x is x squared. What comes next?
Minus 6x.
Minus 6x. Remember that's the x times negative 6. Alright?
Minus 6x
Minus 6x.
plus 36.
And notice that's a negative times a negative, so plus 36. Be careful about that. Now what do?
combine like term, or you can multiply like.
I can do either one, right? I can distribute or combine like terms, because plainly put, all we're doing is what?
Simplify.
Simplifying. And then distributing. That's someone else's phone going off, isn't it?
Yes.
Alright. So there is the standard form. In order to get that standard form, all we had to do is distribute. And I'll go ahead and tell you, there's not an easier way to get the standard form. Just distribute. That's it. Or distribute, simplify is what I meant to say. Did it ask us to just do standard form though?
Yep, sadly no.
Sadly, no. We started with factored form. We got standard form. What do we still need?
Vertex.
Vertex form, right? There is an algebraic process called completing the square. It's a pain in the butt. It's not terrible, let me clarify it. It takes time to learn it though.
Completely.
It's called completing the square.
What is that arrow multiplying? Like that's one x times x and then that arrow is.
Negative 6 times x, negative 6 times negative 6. However, I want to point this out. If it's vertex form, what do we need to write vertex form?
Vertex.
We need the, is it the x-intercepts or the vertex?
Vertex.
Oh,
Vertex.
We need the vertex, right?
Yes.
What else do we need?
A.
A, right? Does anyone know any of those values for this A right here? Right, but first off, and what I would always do is I would write out my equation. What is vertex form?
A x plus,
I feel like you forgot something.
wait, what? Oh, parentheses.
I feel like you're forgetting something.
Y equals,
There we go. We want the equation. Y equals
oh snap, A
A.
times parentheses x. Is it plus?
You tell me.
Yeah, minus.
It's minus?
I don't know. Look at the beginning of lesson 4.
It's minus h
Minus H.
and then parentheses plus square.
Squared plus.
I
Okay.
don't like that. Exponent.
I mean, you can not like it all you want. If you don't have it, is it quadratic?
No.
No. Okay.
Because I've been putting it awkward. I've never paid attention to it.
Until now.
Well, we need to.
So now.
I'm sorry that I didn't notice you weren't paying attention to it, but if you don't have that square, it's not quadratic. So do we know any of the values for that equation already?
A,
Anyone know what A is?
-2.
-2, right? Notice we had A from the very beginning. What do I still need? H and K. Does anyone know how we might discover H and K? Do you know how to graph that by hand?
So on the root, we can do it in the calculator.
We can do it on the calculator. Because let's be real, graphing stuff by hand, we got technology for that, right? So let's go to the calculator.
It makes sense.
Crazy. You have a house. Bring your own food.
Nobody feeds me, okay?
I'm gonna start emailing your mother. Hey, Gracie needs food for class.
Yeah, Gracie doesn't get fed. Well, it's the thing is, when I wake up, nobody's there, and so I
You can
just.
have like cereal at the house, bagels.
I know I don't wake up in time. I wake up 5 minutes before the bell rings, and I get
That
here.
sounds like a terrible
I
idea.
get here at exactly the time the bell
That
rings.
sounds like a terrible
I speed
idea.
walk up here.
All right.
It is.
Yeah. So I'm gonna go to graphs. What am I gonna type into graphs here? The equation. Which one? It doesn't matter.
Right.
So did you say the right one? So look at the. Was it x plus 1 times x plus 4? Is that what it was originally? Yeah. So I want you to notice that was that was A, but we also got -2x squared minus 10x minus 8. Notice, does it matter which equation I put in? No, because those two equations are what?
Correct.
There's another word I want. Equivalent, right? They are the same. They look different, but they're the same. They're equivalent, right? That's why we talked about that so much in the first unit that we did. Now, can we all agree that that's a pain in the butt to look at? It's going to be hard to find the vertex right now? Yes? Okay. So, I want you all to hit menu, hit tab. The other way to do it, remember, is everything runs through menu. And so you can go to graph and choose slash edit that way. But I was just showing us that they're the same. You only have to do one of them. Okay? So, where are we going to go, do you think, to be able to see the line grid that I usually show you?
Analyze where, never mind.
Not trying to analyze it, but change the view. Anyone see where we might be able to add the lined grid? Grid. Okay? Please look at your options. They've named these things for a reason. Go to grid and then lined grid.
That's very.
Okay? Man, that's still not great, is it?
No.
No? Hmm.
It doesn't.
If only there was a way to find that point without doing too much work.
Axis of symmetry.
Okay, so maybe the axis of symmetry.
X equals H.
X does equal H. Do we know what H is though?
No.
We could find it, but how about this instead? Everybody hit menu again for me. Let's analyze the graph this time. Does anyone see anything that we might want that might be the same as the vertex? Was that vertex a maximum for the graph?
Yes.
So remember, we don't have an intersection. An intersection is between two different functions. Nothing's intersecting. But if you look back at this vertex, what else could we call this vertex? The maximum.
So if the graph is upside down, will we say the minimum?
Correct, right? So if it is a concave,
Down.
that's concave down.
Whoa.
Notice concave down has a maximum.
Okay, well.
Concave up has a minimum. For it to open up, it has to have a minimum, okay? So let me show you how to do this on the graph. So make sure we all have this open. Analyze graph. Click on maximum.
Mine says lower bound question mark.
Correct. If you have multiple graphs, which I have multiple graphs in here, it'll ask you graph first. So just click on the graph. But then, yeah, it's going to say lower bound. When we say lower bound, you see this dashed line right here? It just needs to be lower than the maximum. Is this currently lower than the maximum?
Yes.
And what we mean by that is to the left, right? Is it less than the
So
maximum?
when A is maximum, it calls.
So you can click or hit enter, Now that I've hit enter or clicked on it, it's now asking me for what? Upper bound. And then so you go somewhere to the right. And you'll even see that shaded region so that you want to make sure your maximum is in there. You haven't put in your equation yet? So you have to put your equation in first. So put in a function.
That's weird.
So type in the equation for that function.
I don't think I did.
When Taylor comes on the left.
So make sure you go, okay.
Never mind, I
You
did.
make sure you found it-ish.
But A is.
So hit menu again,
I use mine on the.
go to analyze,
You can move it to.
and maximum.
Enter.
And then notice how it says lower bound, so you need to be to the left. You are currently to the left, so hit enter.
Upper bound,
Now once
enter.
upper, so go to the right, so that you're above the maximum.
Is that what yours is?
Don't scroll. No, you're going up. Scroll to the left. There you go. Have you found the maximum now?
I get it.
Are you to the right of the maximum? You're making that way harder. You just have to go to the right. Just hit enter. You're to the right. Hit enter. There it is. So notice, what is our maximum? What is our vertex? And Jeremiah, remind me to check to make sure you know how to do it in a second, okay? Negative 2.5, comma, 4.5. Now that we know the vertex, what am I going to do?
Plug it in.
Substitute in. Y equals, what was our A value?
Negative 2.
Negative 2 times x
Minus 2.5.
minus 2.5.
Wouldn't it be plus because it's 2 and negative?
So remember, we are subtracting a negative 2.5, so it would be positive. Remember, with the x, it's always the opposite. So x plus 2.5 plus 4.5. That's it. Oh, it's quadratic, so I need to square that joker. Hey, there's my vertex form. Huh?
There's an ant
There's an ant
on him.
on him.
There's an ant.
Don't make it weird. There we go. It's dead.
Aw.
Who was there first?
He's dead now. So, does that make sense of how we can do that? Okay. So this is known as, this part right here on the inside is known as a perfect square trinomial. You don't have to worry, or a perfect square. You don't have to worry about it. Literally it's called a perfect square because it's being squared. But you can go through a lot of algebraic work, whereas you could just graph it and be done. That's way easier, yeah? Yes, okay, cool, good talk. So now we're going to look at the B. How do you, we already have standard form for B, right? What form do we still need?
Factored inverted.
Factored form? Any guesses how I'm going to get that factored form?
Graph.
Could we graph it again? Because what things do I need for factored form?
So this whole time we
Oh, we know R1 and R2, right? So make sure you make this note there that, hey, we want factored form. Let me erase some of this stuff. Okay?
Like, is that?
So we want factored form. And what is that factored form? Y equals A.
A parentheses.
What is that one?
No.
X, yeah, X
Minus R1.
minus R1.
X minus R2.
Okay. So what again? What things do I need? The x-intercepts and A. I want to point this out because it's going to come up in a second. Have you ever thought it was weird that we call it R1 and R2?
No.
No, you're just like accept it. It's like that's the thing, Mr. Kenny. X-intercepts are also known as roots.
Yeah, in the book it says.
X-intercepts are also known as the roots of the function, right? We say x-intercepts because it's crossing the x-axis on the graph, but that is also known as the root of that polynomial. There are some roots that don't have x-intercepts, and so we'll talk more about that in lesson 6. But, so yeah, what am I going to do to get those roots that I need? Graph. Alright. So I'm going to delete. Get rid of that. Okay, so what was it? 2 times x, was it minus 6 squared?
2x squared.
Then plus 5 maybe? Does that sound right? So Jeremiah, put it into the calculator so that when we get to the graphing part, we can get there. Say again.
How do you clear it again?
So hit tab, well, so remember, you're going to graph, right? So you can either hit tab or go back to menu and go to the graph entry /edit. Remember, you're trying to hit escape from there. So you go to menu, and graph entry / edit. Nope, we're trying to create a graph load. And you're trying to create a function. And so if you scroll up, you can actually see the previous equation. Just delete the previous equation. Right? And type in this equation there. So you can just delete the, what did you go to? Hit menu again. Where did you go?
I went to graph
Mhm.
and then I did different equation.
No, diff EQ, no man. Function, you're graphing a function.
Yeah.
Yeah. Scroll up, delete the previous one, and add this new one in there. Oh! Interesting.
No, not interesting.
It is interesting.
It's complicated.
It's not complicated. There's our graph.
I don't like
What do we not have?
see anything.
We don't have the minimum?
I don't.
You don't have that graph right here?
I have that graph, but like, I'm saying we don't have the, I don't have
The
the
minimum would be the little bottom.
The coordinates of what?
the vertex.
Of the, we don't have the coordinates of the, I mean, we started in what form? What are we trying to get? Okay, the x what? Intercepts. I don't have x-intercepts. So can I get factored form this time? Okay, that's it. We already had standard. Remember we did that earlier. Oh yeah. So I want you to notice there are no x-intercepts, so we can't get factored form. At least yet. Yep. Remember those complex numbers
No,
that I talked about
I
earlier?
want to forget them.
I want to forget them. Yeah, there's these things called complex numbers that will allow us to get the roots, also called zeros or solutions. Okay, so I want us to notice, to get standard form, what process are we going to follow? What process? We're going to simplify, right? Say again. Okay. To get standard form, we're just simplifying. To get factored form or vertex form, we're going to what? Graph and get the vertex or get the x-intercepts. So make sure you make that note. To get standard form, we simplify. To get factored form or vertex form, graph and pull those features.
Can you say that last part, like, to get?
The part about getting to get factored or vertex form.
Mhm.
Okay, so to get factored or vertex form, graph and pull the proper characteristics. I'll say it that way, right? Because again, if I have vertex form, what do I need?
The vertex.
The vertex. If I have factored form, what do I need?
The A.
I mean, I always need A, but if I have factored form, I need the x-intercepts. Okay? Now, I do want to point this out really quickly. Remember how we went to analyze graph to get the maximum for the vertex? And you can do the minimum to get the vertex? You don't need to type this in, because obviously we don't have any x-intercepts right now. But notice analyze graph. Does anyone see another term that might go for the x-intercepts? They're also called roots, but there's another name for them. No, that's all calculus down here.
Minimum.
Zero. Because I want you to think about it. What do we know about the y value every time for an x-intercept?
Zero.
The y value is 0. Okay? So there's this weird thing where x-intercepts, depending on how we're talking about it, have like 5 or 6 different names. The x-intercepts are called x-intercepts because they're intersecting the x-axis. They're called zeros because the y value is 0. They're called roots because that is known as the root of the polynomial. Am I missing any others? And they're also called solutions sometimes, and we'll talk more about that later. But there's all these different names for it. Woo! It's a lot of stuff, yeah?
Yeah.
Great learning. Yeah. Okay, let's look at 4.3. We need to try to get through this so we can start on lesson 5 next week. So here's what we're trying to do now. To get more practice with it, we're trying to use key characteristics. Use those key characteristics of specific forms of quadratic functions to write equations. You have to know how to write equations to do the next part of the lesson. So with 4.3, we are writing a unique quadratic function. Alright, you've used properties of linear functions to write linear equations. You've also used properties of exponential functions to write exponential equations, right? Now it's time to do it for quadratic. So, George and Pat each wrote a quadratic equation with a vertex of 4, 8. Analyze each student's work, describe the similarities and differences in their equations, and determine who is correct. Mostly I just want you to focus on determining who is correct. Talk for 60 seconds, figure out who you think is correct between George and Pat. So, George and Pat wrote 2 different equations with that given vertex. Who do you think is correct?
Yeah, like the one half.
Why not?
I think George is wrong.
Why?
Because he didn't simplify all the way. Like he didn't distribute.
I don't either, but does it tell you what A has to be? So is he wrong? Does it tell you what A is up there? So is he wrong?
I just thought like at the end of his, he doesn't have a number.
Yeah, because Pat doesn't have.
If there's nothing in front of it, it could be understood as 1, so. What are you thinking?
I don't like either of them.
Why not? Because they're what? They're just writing equations. Are their equations correct? Could they both be right?
Yeah.
They could because.
Literally.
This one don't have an A.
Now be careful, it doesn't have an A shown, but what could the A be understood to be? The A could be a 1, right?
They are authentic. They're like, George and Bob, they're the same. We play realistic.
What y'all say?
No. You don't understand the math.
Why is George?
George and Pat have the same hair, right? They have different shapes of things.
Yeah, that's like ages 4 and 8. They
It's like how
say 8
Disney,
to K.
like, have you
Could it
seen
be
that
one?
one thing that's like a Rapunzel, like, you can literally just see the reflection of her in her eyes, and I was like, he doesn't miss anything, like, they stop on each frame and they're like, oh,
Let's talk
you
about
can't
it.
see her reflection, and I'm like, who even would have noticed?
Thank you. Nathan, I know you're still talking, and so sorry for cutting you off. Did y'all decide on anything about who might be wrong?
Nobody.
You think, who's wrong?
I thought George was wrong, but at the same time they could both be correct because there is no given A value.
Cameron, what do you think?
What he said, except, yeah, what he said.
What he said? So, in conclusion, who's wrong? Neither one of them. It doesn't give us an A value, does it? No? Do they both have the correct vertex in their vertex form? Yep. So could it be either one? Or could either one be correct? Yes. You have to be given an A to be able to say, no, that's wrong, okay? But yeah, they're both valid. Make that note. They both correctly use the vertex form. Okay? They both correctly use the vertex form. The A wasn't given, so it could be either one. They could both be correct. Okay, now let's talk about this. They've given you a couple of worked examples that you can reference whenever you need. Notice in this first worked example, it says write the quadratic function given the vertex and a point. So what form of a quadratic equation are we going to use? Vertex form, got a vertex, right? But what do they not give us? A. But you can start, and I wouldn't have jumped to where they did, you can start with f of x equals a times x minus what's going to take the place of h?